Hey everyone, welcome to EduKaji. If you're first time here, let me introduce myself. My name is Walter and I am a real life scientist as well as a chemistry tutor for the past 8 years. So I'm actually very well versed with the SPM chemistry syllabus. So for today's video, we're going to take a look into the past trial paper. This is actually for the SPM Trial Selangor paper for the year 2021. All right. So hopefully you'll be able to get some knowledge when it comes to chemistry and also to learn something new from here. All right. Now, without further ado, let's take a look at the question itself. So this is a paper 2 version. This is the paper 2 paper for the Selangor trial paper for 2021. Okay, so it's divided into 3 different sections. We have section A, B, and C. So the first section here for A, it carries a total weight of 60 marks. So we discuss every single question along the way. So let's look at the first question. So the first question here says, table 1 shows the number of protons and neutrons of atoms of elements W, X, and Y. And the letters used are not actual symbols of the atoms. Use the letters to answer the following questions. So we have W, X, Y with the number of protons of 6, 6, and 8 respectively. The also number of neutrons is shown also 6, 8, and 8 respectively. Okay. So in this case now, they ask you the first question, state the term for the total number of protons and neutrons in the atom. So the total number of protons and neutrons is given a special name called nuclear number. Okay, so if you write nuclear number over here, you will technically get 1 mark already. Okay, so this is your 1 mark if you get correct. Now, they ask you to write a standard representation. That means write the symbol as well as the 2 numbers beside it. Okay, one is written at the subscript and the superscript level. So the superscript level will be number 16 there, you see. That represents the nuclear number of Y. And the 8 at the bottom here, which is the subscript, is actually known as the proton number. So if we take a look at the Y, the number of the nuclear number, like we say, total number of protons and neutrons, is actually supposed to be 8 and 8, so total 16. So we said nuclear number of Y is actually 16. And then the number of protons, as you can see in the table, is actually 8. So the standard representation of element Y is 16, 8. All right, if you write that correctly, you should also get 1 mark in total, technically. And then for question C, state a pair of isotopes in table 1. So isotopes are atoms of the same element. All right, and they have the same number of protons, but they only differ in terms of number of neutrons. So if you take a look at the table over here, right, there are only 2 elements which have the same proton number, and that is basically W and X if you see over here. But if you also notice, the number of neutrons is different for both W and X. So as the definition of isotope states that isotopes are atoms of the same element with different number of protons but different number of neutrons. So this table here shows you that W and X have the same proton number but different number of neutrons. So W and X are technically isotopes. So I've already also give you an explanation that both of the elements X and Y, or both the atoms X and Y, have the same number of protons, all right, but they have different number of neutrons. So that's your explanation. That's where you get your 2nd mark, technically. Okay, so that's the answer. If you answer both of that correctly, if you give the answer W and X, you get 1 mark, and you explain that both have the same number of protons and different number of neutrons, you get another mark. So total, you get 2 marks in total. Okay. For D, write the electron arrangement of atom of X. So atom X has technically 6 protons. Okay, so in a neutral atom, inside a neutral atom, there are equal number of protons and electrons. That's why they are called electrically neutral, right? The charges of the protons and the electrons cancel out each other. So since X has 6 protons, technically X also has 6 electrons. Okay, so if X has 6 electrons, if you were to arrange them in different shells, I mean, technically speaking, the first shell can only fit 2 maximum, right? And the second shell can fit like 8 and then so on, 8, 8, 8, 8. So since X has only 6 electrons, then the arrangement will be 2, 4. Answer that correctly, you should be able to get 1 mark. All right, let's move on to the question number 2. Diagram 2 shows a medal made of bronze Okay, so name the element that's added to copper to form bronze. So bronze is actually an alloy, and it is a mixture of copper and tin. So the other element that's supposed to be added to copper to form bronze is actually tin. So if you write tin, you can actually get 1 mark. All right, and if you write the symbol for tin, which is SN, you don't get any marks, okay? Because in this question, they actually ask you to name the element. So be very careful not to put the symbol there. Because usually students ask this question, they say, can I actually put the symbol there instead of stating the full name, right? Sometimes because we are a bit lazy to write the whole term, like you see silver or gold, or even sometimes longer like vanadium, or manganese, very long. Can I just put a symbol? If the question says state the element or state the substance, you may. But in this case, they say name. Whenever you see the word name, means you have to put the name there. All right, to play it safe, I would say almost every single time they ask you to state the substance or the elements, just put the full name. Okay, don't put the symbol only. Now for B, they ask you to draw the arrangement of atoms in bronze. Okay, so usually, right, you have 2 different sizes of atoms lah. In this case, because bronze has only 2 different elements present inside, so you have either you actually have copper and you have tin, right? So you must always draw copper atoms having your alloy should have more copper atoms than tin lah. Okay, because tin is the foreign atom. All right, tin is the foreign atom, while copper is actually the main atom inside there. Whenever you have an alloy, right? Alloys are still, pure, the metals themselves having other foreign metals inside, right? So you see over here, the one that I draw over here, the smaller ones, I mean, this is not draw according to scale, all right? But the smaller ones, if you see, the frequency is actually higher. So the smaller ones, right, actually they are copper. While the one that's bigger, right, inside here, over here, that's actually the foreign atom, and that's actually your tin, supposedly lah, okay? That's supposed to be your tin. So the foreign atom inside there should have lesser amount compared to the main atom, the main metal itself. So they should draw in this manner. You should be able to get 2 marks in total. Okay, next C. Why is bronze more suitable for making metals compared to copper? All right. So usually pure metals, although some of them are shiny, but over time they become very dull in terms of the texture. So when you perform alloying, there's one advantage where alloys has this nicer physical appearance compared to the pure metal, right? So in this case here, bronze technically has a shinier appearance compared to copper. That's why it's more suitable to be making metals. I mean, if you win a particular competition, say for example in a race, you win a competition, obviously you want to win a medal which is shiny, right? You're going to put it on your neck, you'll be proud of it. So therefore, bronze, being an alloy, should have a nicer and a shinier appearance compared to its pure metal, which is copper lah. Okay, so once you indicate that there's a nicer physical appearance compared to its pure metal in this case, then most likely you'll be able to get 1 mark over here. Next one, name other alloy of copper. So copper has 2 alloys. One is called bronze, and the other one is called brass. Brass has this a little bit lighter color and slightly more towards gold kind of like color. So that's usually made into musical instruments, that kind of. So therefore, the answer here is brass. All right, let's go to question number 3. Diagram 3 shows the apparatus set up to determine the empirical formula of oxide of copper. Okay, so if in your typical magnesium oxide experiment, you actually heat up the magnesium in air, right? So that the magnesium can react with oxygen. Then from that reaction, you can actually calculate the amount of oxide that's formed, and then you get the mass of oxygen over there. However, in this particular reaction, you can see over here, this is the opposite. To calculate the mass of oxygen, we actually steal the oxygen away by using a reducing agent. So hydrogen gas, being more reactive than copper, according to the reactivity series, is technically able to steal away the oxygen from copper. Or we should say that hydrogen gas can reduce copper oxide to just copper, okay? So the loss of mass of the oxide corresponds to the mass of the oxygen lah, okay? So that's the idea of the experiment. So A asks, what is the meaning of empirical formula? So empirical formula is a formula that shows the simplest ratio, okay? It shows the simplest ratio of the atoms of each element in a particular compound. All right, you must have these keywords inside: simplest ratio of the atoms of each element in the compound. Then only you'll be able to get 1 mark lah. Okay, but the idea is very simple. Simplest ratio must be inside. And then for B, table 3 shows the results of the experiment. So they have the mass of the combustion tube, and then the mass of combustion tube plus oxide of copper, and then the mass of combustion tube of copper alone. Okay, so to calculate the empirical formula, which is the next question, all right, you're supposed to be able to calculate the mass of copper alone, and also to get the mass of oxygen alone, so that we can calculate number of moles, compare the ratio number of moles, and then only you'll be able to get the empirical formula. All right. So you have 3 different columns, I would say, 3 different parts over here. So you have, let's just say, for example, we have like 1, 2, and 3. Okay, 1, 2, and 3. So for you to get the mass of copper alone, you take 3 and you deduct with 1. Then you'll be able to get the mass of copper only. If you were to take 2, all right, 2 deduct by 3, then you'll be able to get the mass of oxide, which is technically your oxygen. Okay, so that makes a lot of sense. So once you get the mass of the copper and oxygen alone, then you'll be able to calculate the empirical formula. So right now, after you deduct off already, based on the explanation that I gave you, you realize that the mass of copper is actually 12.8, and the mass of oxygen is actually 3.2. Okay, then you divide the mass that you get for both copper and oxygen individually with their respective relative masses, which means here, the 64 is the relative atomic mass of copper. So 12.8 divided by 64, you get 0.2 moles. All right, and then for oxygen, 3.2 divided by 16, which is the relative atomic mass of oxygen, you'll be able to get 0.2. So since it's a 0.2 to 0.2, the ratio is technically 1 to 1 lah. Okay, so if it's 1 to 1 ratio, then the empirical formula should be CuO. You are required to actually show all of the workings, including how you get your mass for each substance, before you can get all these 4 marks. So you have to show the calculation, remember this. And if you can, of course, I will highly encourage you all to actually draw a nice table, which means draw a nice table, all right, separate the different columns over here. It makes it look nicer, I would say, okay? So for this example, I'm not going to show you the table, okay? You just have to draw it on your own, use a ruler, make it nice, then you should be able to get full marks already, right? Impress and make the examiner happy, I would say. Happy examiner means happy marks. See, the empirical formula for magnesium oxide cannot be determined by using the same method. All right. So say, for example, right now we want to get the mass of magnesium oxide. All right. And I want to calculate the amount of oxygen that's formed and things like that. But you realize that you cannot use magnesium oxide to calculate empirical formula as what we've seen as the earlier part, which is the copper oxide one. So the question now for C is that why can't we use magnesium oxide for the same experiment to calculate its empirical formula? The answer is because magnesium is more reactive than hydrogen. So magnesium cannot be reduced by hydrogen, you know what I mean? The idea is very simple. For the experiment to work, hydrogen must be more reactive than the other substance, the other metal. So if right now what we say is that magnesium is more reactive than hydrogen, then how can hydrogen actually steal away the oxygen from magnesium? It's technically impossible, isn't it? So hydrogen here is unable to reduce magnesium oxide to magnesium because magnesium is technically more reactive compared to hydrogen. So therefore, this reaction doesn't work with hydrogen. All right. Now let's move on to question number 4. Diagram 4 shows the part of the periodic table of elements. A, B, C, D, E, and F are not actual symbols of the atoms. Use the letters to answer the following questions. So let me highlight a very important part based on this question alone. Whenever they say use the letters to answer the following question, what they're trying to say is that you cannot actually use the exact or the real elements based on the position in this particular periodic table. You have to use the letters to answer the question in this section. Meaning to say, of course, we know that the first two elements over here is hydrogen and helium, right? And then we know that A is actually lithium, correct? Based on what you all learned before, you know that A is lithium, okay? And then after that, of course, E is also potassium, we know. But we cannot write lithium inside if your answer is supposed to be A. You cannot write potassium if the answer is meant to be E, for example. So you have to use back these A, B, C, D symbols that they give you, okay? I would say, jangan pandai-pandai lah. Simply go and write the actual symbol inside. I know that most of you are very smart and very well versed in chemistry and SPM. But, you know, rules are rules. You have to follow how the question is set. And if you ever see this kind of like question in your SPM exam or your trials or whatever exam paper that you have, make sure you use back the same symbol if they ask you to. Most of the time, you have to use back the same symbol, okay? Never use back the actual symbol of the elements, although you know that those are correct in terms of the periodic table. Okay, so here, elements A and E can react with gas D to form more white solid. All right, so between elements A and E, which is more reactive when reacting with gas D. So A and E falls under the same group. If you see here, technically it is group 1. All right, and they are both very reactive. But the question is, which one is more reactive? Because they're asking you which one is more reactive. So the answer here is E, okay, because E is located lower compared to A in the same group. All right, we know that the lower it is in that particular group, the more reactive it becomes. But the question is why, right? Because I asked you to explain why. So you write E over there, you get 1 mark already. But the question is they want you to answer why also. Explain why E is more reactive than A. So the answer is very simple, because you see the size of the atoms is different. E has a larger atomic size, A has a smaller atomic size. So therefore, I would say the protons in the nucleus of A can hold on tightly, or should I say, the attractive forces between the nucleus to the valence electron in A is stronger compared to E. Because the atom is smaller, the valence electron is closer towards the nucleus for A. E has more shells, 2 extra shells compared to A. So the valence shell is further away from the nucleus. The pulling force from the nucleus towards the electrons in the valence shell is actually weaker compared to A. So therefore, the answer is very simple, right? The valence electron of atom E is further away from the nucleus compared to atom A. The attractive forces between valence electron and the nucleus is actually weaker. You must actually explain that the attractive forces between the valence electron and the nucleus is weaker in E compared to A. Now, since they actually ask you to explain anymore, just 2 marks. You just give these two answers, you get 2 marks already automatically. Right, so that's the answer. For the next question, B, elements B and C can react to form a compound used to extinguish fire, okay? So draw the electron arrangement, the compound form. Now, first and foremost, before you draw the structure, you have to know the electron arrangement, okay? So now we see, right, we have B and C, which can technically form, can form a compound, which is supposed to be carbon dioxide, if you think about it, right? Because B is technically carbon and C is technically oxygen, okay? But again, we are not going to use the actual symbols. We're going to use B and C. Okay, now how do we know the electron arrangement of B and C if we technically don't know what elements they are for now, okay? We can look at the group and the period. So this is group 1, 2, this is 13, 14, 15, 16, 17, and 18, correct? So B is located in group 14, which means it has actually 4 valence electron, and C is in group 16, it has 6 valence electron. The fact that both B and C is actually located in period 2 tells you that they have 2 shells. So for B, the electron arrangement is supposed to be 2, 4, and for C, it is 2, 6. So using this information that we can get from this periodic table over here, we'll be able to draw the atoms and see how many electrons they can share. Supposedly B and C, they're located in the area where they're nonmetals. So when nonmetals and nonmetals combine together, they actually form covalent compounds. And this is actually a simple covalent molecule. All right, so to achieve octet, B needs 4 more electrons, C needs 2 more electrons. So technically, when they share electrons, I will say that 2 atoms of C will share 2 electrons each with B, so that all of them can achieve octet. So if you were to draw that structure, it looks something like this. Okay, so I've already indicated to you that they actually share 4 electrons on both sides. And then after that, what they'll have is an octet electron arrangement for both B and atom C lah. Okay, if you draw this correctly, you can get 2 marks. All right, so what I use is a cross and dot diagram lah. All right, for the atom of B, the electrons are in the form of dots, and then the atom C, we use crosses as their electrons. Then you'll be able to get correct already lah. Okay, in this case. 2, explain why the compound is suitable used for extinguish fire involving electrical appliances. So they are hinting you about electrical appliances lah. So usually fire that is caused by electrical appliance is based on sparks being produced by electricity. So anything that can actually promote or to conduct electricity may cause the fire to become worsened. All right, to become worse lah. So in this case, we know that carbon dioxide, or should I say BC2, so BC2 or carbon dioxide does not conduct electricity. They are covalent compounds, all right? They are made of molecules, and molecules are electrically neutral. They don't have any charges because they have no ions, so therefore they can't conduct electricity. So your selling point here is very simple. It cannot conduct electricity in all states. So if you use it to put out a fire, it is effective. So that's 1 mark. Okay, now next, element F is used in Haber process to increase the rate of ammonia production. If you know your Haber process well, then you should know that actually, it is iron. Element F is supposed to be iron. So state one other special characteristic of element F. When they talk about this special characteristic, they're actually referring to the special characteristics of transition elements or transition metals. And you know that there are a few very unique features of the transition elements, right? First of all, you can write either they form colored compounds, which they do, right? Like for example, remember we talk about different kinds of transition element ions, like copper 2 will be like blue, manganese 7 is like purple, chromium 6 is like orange, and iron 2 is like green, and so on. So different charges or different oxidation states of different transition elements, they have different colors. So if they are combining with other non-metal, for example, they can form colored compounds. All right. Second one, you can also write, if you want, like, can actually use different oxidation states. So we know that different metals have different oxidation states. Remember, like iron got iron 2 and iron 3, copper got copper 1 and copper 2, chromium got chromium 3 and chromium 6 and whatnot. So there are different oxidation numbers for different transition elements, okay? And the last one will be you can form complex ions. So that's another selling point where you can form a lot of complex ions. Like for example, iron can form things like hexacyanoferrate 3, hexacyanoferrate 2, all those kind of different complex ions. So these are the 3 different unique properties of transition elements. But of course, you can choose any one of them will do because it's just 1 mark and they only ask you for one other special characteristics. So as long as you write 1, you can get 1 mark already. Question number 5. Diagram 5 shows an apparatus set up for cell A and cell B. Zinc sulfate solution, copper 2 sulfate solution, and concentrated copper 2 chloride solution are used as electrolyte in this experiment. If you don't know what's going on, technically speaking, cell A and cell B are different cells, okay? So it's actually 2 different sections, okay? For cell A, it's supposed to be a chemical cell or a voltaic cell. For cell B, it's supposed to be an electrolytic cell, okay? So what happens here is that cell A is technically supplying electricity because, right, chemical cells produces electricity, and the electricity produced is then used to electrolyze another substance. In this case, it will be concentrated copper 2 chloride solution. Okay, then they also give you a list of standard electropotential values. all right, with different substances over there. You can use this as a reference later to calculate the voltage of the cell. So referring to cell A, which is in this case is actually the voltaic cell, the chemical cell, explain or state the metal that acts as a positive terminal and explain your answer. Okay, now, between these two substances over here, you have one which is copper and one which is zinc. Okay, so if you follow the electrochemical series, right, zinc is technically more negative, or should I say more electropositive compared to copper. How do we know? Look at this. So we have copper, we have zinc, and zinc's value is more negative than copper. So when the more negative the value is for the standard electropotential value, the more likely it becomes a reducing agent, and the more likely it is oxidized. And the one that becomes the reducing agent is actually the negative terminal. And the one that becomes the positive terminal will be the one that's less electropositive, or should I say they have a higher or a more positive standard electropotential value. Okay, so again, one more time, zinc is actually more negative, right? Negative standard 0.76, while copper is more positive. So copper becomes the positive terminal and zinc becomes the negative terminal. So I've already stated here over here for you, copper is the positive terminal because it has a more positive standard electropotential value compared to zinc. So if you were to state the metal plate that acts as a positive terminal, you get 1 mark, and then explain why you get another mark. So 2 marks in total. And then you ask you to write an ionic equation for the reaction that occurs in the cell. So this is how you write the ionic equation. For those of you who do not know how to write ionic equation directly like this, what you can do is that you can always write 2 half equations. So if you look into this part over here, all right, between copper and zinc, all right, you have to ask yourself what's going on in this particular cell. So zinc being the more electron positive one, tends to become the reducing agent, right? So it becomes oxidized. So how does it oxidize? So in a chemical cell like this, zinc will dissolve into this electrolyte to form zinc ions, and they will release 2 electrons, right? And at the other side, at the copper side, because you have copper 2 sulfate solution over here, you have plenty of copper ions inside, isn't it? So copper ions will be the one that accepts the electrons, right, to become copper atoms. So to write ionic equation is very simple, okay? So you see in these 2 half equations, you just have to combine them together because it's called half ionic equation, isn't it? Half equation can combine together to form the overall ionic equation. So what you can do is very simple technique, okay? You take whatever is before the arrow, you put them together. And in this case, you also ignore the electrons. So just cut them off. And whatever is after the arrow, put them together. Okay, so if you do this correctly, this is your overall ionic equation. And this is the part where you are supposed to insert it over here. It's exactly the same. It's just that I turned the zinc and the copper around, and that's it. You can write it any orientation that you want. You can put copper first if you want to. You want to put zinc first also can, no problem, actually. Write this correctly, you should get 1 mark. Calculate the voltage of the cell for the chemical cell between zinc and copper. Now, this is very simple, all right? To calculate the voltage of the cell, you just need to remember one thing. The formula is very simple. The formula is voltage of the cell is equivalent to the electropotential value of the positive terminal, okay, of the positive terminal minus the standard electropotential value for the negative terminal. So if you refer to the table that I showed you just now, right, in this question, you already have all the values over here, right? So we have the copper one and we have the zinc one. So since we have the positive terminal at 0.34, positive 0.34, and the negative terminal is negative 0.76, So just take these two value and then you substitute it inside here. All right. And then after that, you'll be able to get the value, which is positive 1.10 volts in total. All right. Very simple one. If you calculate them correctly, you should be able to get 1 mark. Okay, next. Referring to cell B, which is technically the electrolytic cell, name the gas P that is being produced. So in this picture over here, what happens here is that there's a gas P being produced. So this is actually supposed to be the anode and this is the cathode lah. Okay, so this is how it works. And then after that, if you notice over here, the gas P is supposed to be chlorine. Okay, so the next question will ask you why. Why is it chlorine? Because supposedly, right, in a concentrated copper chloride solution, okay, see, concentrated copper chloride solution, what do we have in the inside? So we have in copper chloride concentrated form, you should technically have copper ions inside. We should have chloride ions. We'll have hydrogen ions from the water and hydroxide ion from the water as well. Now, of course, we don't take a look at these two because these two are technically cations. They are positively charged ion that's going to be discharged at the cathode. But now we're referring to the anode, correct? So they're at the anode. So at the anode, you have to choose between chloride and hydroxide. So how do we choose? How do we know which is being discharged? Now, since it's a concentrated solution, there will be more chloride ion compared to hydroxide ion. So that's why I explained to you over here, the concentration of chloride ion is greater than hydroxide ion. So that's why they are chosen for discharge. But how does the gas how is the gas produced? The gas is produced when two of the chloride ions combine together to release the electrons out, and then they form one molecule of chlorine gas. That's it. So if you were to state this on top here, you get 1 mark. Explain how this gas is formed, you get another mark. So total, you get 2 marks. All right, and then they ask you to write a half equation for the reaction and the cathode. So as usual, as we follow the standard electropotential values, we realize that in this case, the more positive the value, the easier to discharge lah. Okay, so you can see here between hydrogen and copper, you will notice that copper is more positive than hydrogen. So that's why copper is chosen for discharge law. So you can just write a half ionic equation over there. In this case, it will be copper ions receiving 2 electrons to form copper atoms. That's it. And then from there, you'll be able to get 1 mark. All right, let's look at number 6. Diagram 6 shows the apparatus set up to determine the heat of precipitation for silver chloride. So we have 2 different substances added together. We have 50 cm cube of 0.5 mole per dm cube of sodium chloride solution. And then we also have 50 cm cube of 0.5 mole per dm cube of silver nitrate solution. So we have sodium chloride and we have silver nitrate added together. And this is actually supposed to be a double decomposition experiment where we want to create an insoluble salt. They give you the initial temperature of both of the solution, which is 29 for both. So the average temperature is 29 lah. Okay, and then after that, the highest temperature achieved by the mixture is 32 degrees Celsius. So in this way, we'll say that the differences between the two, all right, or as I should say here, the temperature change is actually 3 degrees Celsius lah. All right. Now, the first question asks you what is meant by the heat of precipitation in this reaction. The heat of precipitation must be the heat released. Okay, now, in this case, I use the word heat released because I see that the temperature actually increased by 3 degrees Celsius, right? So if the temperature increased by 3 degrees Celsius, means it's an exothermic reaction, right? It's hotter. So that's why I put a heat release instead of heat absorbed. So heat release when 1 mole of silver chloride is displaced in its aqueous, so not displaced, wrong choice of word. It's formed. Okay, let me just change that. So this is supposed to be formed. Okay, that's a better choice of word. Not displace. It's not displacement. I'm sorry. It's supposed to be formation. So heat released when 1 mole of silver chloride is formed from the aqueous solution that contains both silver and chloride ions. Supposedly 1 mole of silver and 1 mole of chloride ions lah. Okay. Then if you get that, you should get 1 mark already. State one observation in this experiment. So we must explain what happens when these two solutions added. So the one observation that I can see obviously will be the formation of the precipitate. And this silver chloride precipitate has a white color lah. So therefore, I said that white precipitate over here is formed. Then you get 1 mark already. For the next question, the chemical equation for the precipitation for silver chloride is as follows. Calculate the heat change of the reaction. So they even give you the specific heat capacity of the solution, which is 4.2 per gram per degree Celsius. So 4.2 joules per gram per degree Celsius. And you also have to assume that the density of solution is assume 1 gram per cm cube. Okay. So we have to use this formula called Q is equivalent to MC theta to calculate heat change. Okay. Now, the mass of the solution is the total mass, or should I say the total volume of solution after both have been added together. So if you see the question as now, you see here, we have 50 cm cube of sodium chloride and 50 cm cube of silver nitrate, right? So obviously 50 plus 50. Okay, 50 plus 50 is 100 cm cube. And the question actually asks you to assume that the density of water or the solution is 1 gram per cm cube. So therefore, 100 cm cube of solution is technically equivalent to 100 grams lah. Okay, so that's why I put here supposedly lah. This is supposed to be 100 grams. Okay, so 100 grams plus 4.2 joules per gram per degree Celsius, which is given here already. And then after that, we have a heat, the temperature change. Theta over here means temperature change. So as we calculated earlier, there's an increment of 3 degrees Celsius, right? 29 degrees Celsius on average increased to 32 degrees Celsius. So therefore, 3 degrees Celsius change. So if you were to sort of like multiply all of them together, you'll be able to get 1,260 joules as your answer. So later on, you have to calculate delta H value, which is the heat of the precipitation. So what I like to do is I like to convert the joules straight away into kilojoules, because to calculate delta H value later, you need to make sure that your value, the Q, is supposed to be in kilojoules already. So divide by 1,000. Okay, so joules to kilojoules is just divide by 1,000. So 1,260 joules divided by 1,000, you get 1.26 kilojoules in total. And that will technically give you 1 mark. And then to calculate delta H, which is the heat of precipitation of silver chloride, very easy. The formula is this. Delta H is equivalent to Q over N. We just calculated Q, so Q is there already. The question now is, what is N? N refers to number of moles. Number of moles, what? Number of moles of silver chloride being formed. So what we can do is we can actually use the information that we get from here, right? So we can just take any of this value over here. In this case, right, you can take any value here. 50, 0.5, 50, 0.5. They're the same, actually. So if we get these two together, the volume and the concentration of the solution, right, based on the equation, they are all 1-to-1 ratio. So if you can calculate any one of the concentration of the solution, either silver nitrate or sodium chloride, you'll be able to get the number of moles of silver chloride being formed. Okay, so I took any of those, it doesn't matter. 0.5 mole per dm cube, 50 cm cube, divide by 1,000. So that's MV over 1,000. That's to calculate number of mole. Then I realized that number of mole is 0.025 moles. So if this solution over here is 0.025 mole, this one is also 0.025 mole, this one is also 0.025, this one also is 0.025, because all 1-to-1 ratio. So now that we have the number of mole of silver chloride, we can then substitute the value into this formula over here. So 1.26 is the one that we calculated earlier for Q, and now 0.025 is the one that we calculated for the N earlier. So right now, if you just use your calculator, divide the values together, then you'll be able to get 50.4 kilojoules per mole. Now, one very important thing to remember is to remember to include the negative or the positive value, okay? Negative value means exothermic reaction. Positive value means endothermic reaction. So how do I know when to put this negative or positive? So you look at the question itself, okay? The question here says, right, the temperature actually increased from 29 to 32 degrees Celsius. That tells you that it is actually an exothermic reaction already. So in this case, if it's an exothermic reaction, you must have a negative delta H value. So therefore, let's add negative value there. Then you'll be able to get 3 marks already. Very simple. All right, so based on the change in temperature in table 6, state the type of reaction. So the answer here is exothermic reaction, as I explained to you already. Okay. E, 0.5 mole per dm cube. Oh, sorry. The experiment is repeated by using 50 cm cube of 0.5 mole per dm cube of potassium chloride solution to replace the sodium chloride solution. What is the change in temperature for this reaction? Explain your answer. Okay, very easy, right? Imagine right now, right? That's what we saw. We use NaCl plus AgNO3. You will get AgCl plus NaNO3, right? So if you were to replace this with potassium chloride and using the same equation, you realize that it is the same thing. The number of moles will not be able to change in this case. Do you see that? You will still get 1 mole of silver chloride for both sides. It's just that the difference is that there is a sodium and there's a potassium ion. But these are all spectator ions. They're not involved in the reaction. So since it's a 1-to-1 ratio still, you should be able to get the same change in temperature. So to explain the answer is very simple. You can just say that it is the same, which is 3 degrees Celsius, because the number of mole of silver chloride is still the same. Okay, of course, you can just ignore this and put that 3 degrees. Okay, just ignore this and just put 3 degrees. Because when I type the answer out, I can't actually put degree there. So I just put that 3 degrees Celsius. But you can just write 3 degrees Celsius, no problem. So you get 2 marks over here. All right, let's move on to the next question. This is number 7. So table 7 shows the information of 2 sets of experiments to investigate the factors affecting the rate of reaction between calcium carbonate and hydrochloric acid. So set 1 and set 2, if you see properly, you realize that the mass of the calcium carbonate and also the concentration and volume of acid is the same. The only thing that's different here is actually, one, we use calcium carbonate powder. The other one we use chips. So powder is fine. Chips are larger in terms of particle size. And you can see that the time taken for the carbon dioxide gas to get around 40 cm cube is only 33 seconds for the set 1 and 45 seconds for set 2. So write an ionic equation for this reaction. So same thing as earlier question I showed you. You just have to write what happens in the chemical reaction itself. In this case, the hydrogen ions react with the calcium carbonate to form, the carbonate ion, carbon dioxide, and water. Write that correctly, you should be able to get 1 mark already. Okay, and then after that, they say compare the rate of reaction between set 1 and set 2. So obviously, don't write like me, okay? What you can do is you can always write properly. You can say that the rate of reaction, okay, rate of reaction of set 1 is greater than set 2. You can also say, besides greater, you can change the word to faster also, okay? Faster or higher. Okay, you can choose any one of those keywords, is fine. Rate of reaction of set 1 is faster than set 2 or higher than set 2 also can. All right, I think higher is a better choice of word because it's a rate. So rates can be higher or lower. So this is higher. So I think higher is a better choice of word. Okay. Right. Number 2. state your answer in 7B with the reference in collision theory. Now, for collision theory, you usually got 4 marks in total. So you must write 4 marks, 4 marks worth of answers. So the first thing to compare, in this case, right, to compare is the size of the calcium carbonate powder. So comparing it to the chips, of course, the powder form will have a smaller size. So that's why the first thing that I highlighted just now was actually particle size, right? Particle size. We'll just change the color of the highlighter for you. Particle size was the one that I explained about just now. So we know that calcium carbonate powder is smaller size compared to chips itself. So if the particle size of calcium carbonate powder is larger, the size is smaller, but the total surface area is larger. So you can also mention that, right? The particle size of the powder form of calcium carbonate is smaller than chips, so that the total surface area for the calcium carbonate powder is actually larger. They get 2 marks already there, right? And then after that, explain what happens if we have a larger surface area. What will happen? Okay, so if a larger surface area means it will lead to even an increase in number of collisions between the reactant particles. Meaning to say the particles of the reactors will collide even more often. The frequency of the collision will increase. If the frequency of the number of collision increases, then the number of effective collisions should also increase. Now, if you were to write all of that, you can actually prove that the rate of reaction will increase. So by writing these 4 points, you get 4 marks in total. And then they ask you to sketch a graph of the volume of carbon dioxide gas obtained against time for set 1 and set 2. Okay, this is how it looks like. Very simple. Okay, as long as you can show a steeper gradient for set 1 compared to set 2, but make sure you must remember they both end at the same point, right, which is the same level, because the volume of gas collected is supposed to be the same. They use the same volume of acid, they use the same concentration of acid, they also use the same mass of calcium carbonate powder. It's just that one is much more fine compared to the other one, which is larger in size. Okay, so you have to label the sets also. Very important to show which graph is which. So I put the top graph as the top curve as set 1, because it has a steeper gradient, and set 2, which is the bottom one, because it has a less steep gradient. The higher the gradient, the greater the rate of reaction. Okay, so this is how you draw the two graph, right? This is just a sketch. So you get 2 marks already. A student wishes to increase the rate of reaction for set 2 by changing the hydrochloric acid with sulfuric acid of the same concentration. So in your opinion, do you think the student made a correct decision? Explain your answer. So if you want to increase the rate of reaction, the question now is, can I also, all right, change hydrochloric acid to sulfuric acid, even though we use the same concentration? Yes. But bear in mind, if you change it to sulfuric acid is actually a diprotic acid, meaning it will be able to produce twice the amount of hydrogen ions compared to hydrochloric acid. Okay, so for HCl, if you dissociate it in water, what happens here is that you get H plus and Cl minus. For every 1 molecule of HCl dissociates, you get 1 hydrogen ion. But for sulfuric acid, it's different. Okay, for sulfuric acid, if you were to dissociate it in water, you get twice the amount of hydrogen ion compared to monoprotic acids like hydrochloric acid. So what I'm trying to say here, of course, the more hydrogen ion is present, the higher the rate of reaction, because more hydrogen ions means more reactant particles, correct? So which means there's more collisions between the particles. Yes, then you get a higher rate of reaction. However, since you have twice the amount of hydrogen ions, you should also technically keep in mind that the concentration of H2 that's produced will be twice the amount also, because more H plus combining together to form H2. So you got more H plus means more H2 before. So that's why my question here is very simple. My answer is very simple. Okay, I say here yes. Yes, the rate of reaction will increase because there are more hydrogen ions that's present. Okay, so that's why I put here yes, 1 mark. Twice the number of hydrogen ions will be present to react with the what's it called, the calcium carbonate powder or the calcium carbonate chips Okay, but since they didn't ask you about the volume of gas, I just want to explain this to you so that you keep this yourself noted Okay, keep it in your mind just in case other question may come up that is similar to this. So otherwise, you just get 2 marks over here. Number 8, diagram 8 shows the apparatus set up to use to prepare soap in the school laboratory. So we have what's it called? Palm oil plus concentrated sodium hydroxide solution that is heated up using a Bunsen burner, perhaps. And then after that, you add a bit of distilled water and sodium chloride solution. This is actually to make soap, lah. Okay, this is to make soap in a smaller scale. So what is the name of this reaction used to prepare soap? The answer is saponification. Okay. Then they ask you to draw the structural formula of the sodium palmitate soap, given that the structure of the fatty acid is already located technically over here. So all you have to do is just to transfer the structure to this part over here. But make sure you got 3 of solar because there's 3 right in total. So we have like the first structure over here, the first structure over here, second one, and then third one. So you got 3 structures in total for the fatty acids. So just remember to put a 3 because there are 3 moles of it. Then let's copy back the same structure as you see on the left side. Then you should get 1 mark already. Very easy. Number 3, calculate the mass of the soap produced if 0.05 mole of soap is produced. So to calculate the molar mass of the soap, you have to check and see, follow this structure over here, okay? Then I did the calculation for you already. Okay, if you calculate all correctly, you should be able to get 278 grams per mole for the molar mass of soap, which means 1 mole of the soap is 278 grams, okay? Then you want to know how much is the soap being produced, isn't it? So the soap over here, you see we have 0.05 mole of soap is being produced. So 0.05 mole multiplied by 278 grams will be technically 13.9 grams. If you get this correction correct, if you get the calculation correctly, you should get 2 marks. Okay, 1 mark for the final answer and 1 more mark for the working of the calculation. Okay. Calculate the mass of soap produced. A student wishes to prepare potassium palmitate soap. What alkaline should be used? So I would say technically, if you want to get a potassium soap, then you use a potassium hydroxide. Just now we saw, right? We're using this one now. This is sodium palmitate. To get a sodium-based soap, you must use sodium-based alkaline solution. In this case, it will be sodium hydroxide. But if you want to get a potassium-based soap, then you must use potassium hydroxide. That's where the potassium ion or the sodium ion is located in. So they give you 1 mark. Next, they ask you about the effectiveness of the cleansing action of agent A and B in hot water. Okay, so you can see here for A, right? You use hot water to wash the clothes. And then you see that after the washing process, the grease stain is removed. Okay, for A, there is a hot water, and then you put agent A inside, and then you start to agitate it, wash it, and then the grease stain is removed. For B is different. B, hot water plus agent B. After you wash already, some of the grease still remains, which means it is not clean when you wash the clothes. So explain why A is more effective in hot water. So the answer is very simple. Soap itself is not effective when it comes to cleaning clothes with grease or any stain. Why? Because soap generally can form scum with hot water. If you don't understand what hot water is actually the ones that contains magnesium or calcium ion. So in this case here, detergent A is more effective because the main idea is very simple. It does not form scum in hot water. Okay, because you're asking you which one is more effective. So stating detergent A is already correct. 1 mark already. And explain why. Because it does not form scum in hot water. The effectiveness will not be affected. So therefore, you get 2 marks. Okay, and then after that, what happens here is they ask you to explain now. You can see here. By using the following materials, describe briefly how to differentiate between soap and detergent. So they're asking you how to technically very simply explain how we can test the efficiency of soap and detergent in hot water. So I'll say very easy lah. All right, you prepare 2 different test tubes, and then you pour equal volume of hot water inside. Very easy. Okay, and then after that, imagine that the hot water contains calcium and magnesium ions. So after that, you put a bit of soap and detergent inside separate tubes, right? So you see equal mass of soap and detergent is added into each test tubes. And then after that, you will see what happens, okay? The one that contains insoluble precipitate is technically the scum. So the test tube that has the scum or the insoluble precipitate will tell you that it is the soap, not the detergent. Detergent got no scum, because why we say this now, all right? Detergent cannot form scum in hot water, but then soap can. So the solution that shows you this insoluble precipitate, which is the scum, is technically the soap, and the other one that does not form a scum is actually the detergent. So explain it correctly, you should get 3 marks in total. All right, let's look at number 9, section B. Section B only carries 20 marks, but you are required to answer 1 question from this section. So usually section B got 2 set of questions now, okay? You just need to remember how to answer them correctly. So 2 questions, you pick only 1. But I'm going to discuss both answers for these both questions anyway, all right? Table 9 shows the information about solution P and solution Q with the same concentration but different pH value. So P has a value of less than 7. And then you can see here it reacts with copper oxide to produce copper 2 chloride in water, all right? And then after that, for Q, also less than 7 pH, and it reacts with potassium hydroxide to form potassium ethanoate and water, all right? So right now, both copper oxide and potassium hydroxide are bases. Okay, they are both bases, but they react differently. You can see they form different substances. So you have copper 2 chloride and potassium ethanoate. So based on table 9, state the names of P and Q and which one shows a higher pH value. Higher pH value means still less than 7, but one could be lower value than the other. And then I ask you to explain the answer, 5 marks. So P is supposed to be hydrochloric acid. How do I know? Because you see, it forms copper chloride solution. So if it's a chloride, means you need a chloride-based acid, and that's hydrochloric acid. All right, how do I know that the Q is supposed to be ethanoic acid? Because it forms potassium ethanoate. To get an ethanoate salt, you need to have ethanoic acid in the inside. So P and Q here done already, 2 marks already, okay? The subsequent 3 more marks, you must explain which one has a higher pH value, which one has a lower pH value. So I explained to you here, Q has a higher pH value. Because why? It has a weak acid. A weak acid only ionize or dissociate in water partially to produce lower concentration of hydrogen ions. On the other hand, P is a strong acid. Strong acids will dissociate or ionize in water completely to produce a higher concentration of ions. All right? So one is a strong acid, one is a weak acid, and it dissociates differently. So because of that, P should have a lower pH value compared to Q. pH value is correlated with the number of hydrogen ions. The higher number of hydrogen ions, the lower the pH value. So we have to take a look at it. So since Q has a lesser amount of hydrogen ions, it should have a higher pH value. While P, which has a higher concentration of hydrogen ions, should technically have a lower pH value. That's it. Because to calculate that, it's very simple. To calculate pH value of an acid is negative log concentration of hydrogen ions. So if you take a look at this, the lower the pH value, the higher the concentration of hydrogen ions. So this is done. We got the answer already. Next, they ask you, if I have 100 cm cube of 0.1 mole per dm cube of solution P, if it reacts with excess of copper 2 oxide to produce copper 2 chlorides and water, you're supposed to write a chemical reaction and calculate the mass of copper 2 chloride produced. So the first step is to actually write the chemical equation, which I already did. Balanced chemical equation will give you 2 marks normally. And then after that, they ask you to calculate and see what is the mass of copper 2 chloride produced. So we know that we are using this much of solution P. We can calculate the number of mole of solution P first. And then after that, we can compare in terms of ratio. So the ratio is very simple. You can see here, right? 2:1 ratio, right? 2:1 ratio. So in this case, the number of mole of HCl can be determined by using the formula MV1000, all right? M is the molarity technically. And then after that, V is the volume of the solution. So if you calculate it correctly, you can get 0.01 mole of HCl. So in terms of copper oxide and copper chloride, you can see here, for every 1 mole of, for every 2 mole of acid, you get 1 mole of salt. So it's a 2:1 ratio, I would say. 2:1 ratio. So you calculated earlier that we have 0.01 mole of HCl, correct? 0.01 mole of HCl. So if you have 0.01 mole of HCl, you should have half the number of mole of CuCl2. So that's why I put it over here. Number of mole of CuCl2 is half times 0.01 mole, or should I say 0.01 mole divided by 2. And I get 0.005 mole of CuCl2. All right, now after that, to get the mass of CuCl2, we must first get the molar mass of CuCl2. After that, I calculated already, I get 135 grams per mole of CuCl2. Take the number of mole and multiply the molar mass. You should be able to get your answer, right? 0.005 mole times 135 grams, and you get 0.675 grams of salt being formed. So that's the answer. Get all this correctly, you should be able to score around 5 marks. Done. Very easy. Okay, B is actually what we call as a chemical analysis question. Okay, so white solid W added with nitric acid, you get a colorless solution of Y, and gas V being formed, and then you got water being formed. And then after that, if you heat up white solid W, it turns into solid Z, and then you get gas V, which is CO2. Okay, so they're asking you to identify the different substances of W, V, Y, and Z. All right, and which I already explained to you how I got it. Now, the white solid W, right? You can see when it forms solid Z. Okay, this reaction over here. The subsequent product that's being formed is actually yellow when hot, white when cold. There's only 2 different types of metal oxide that can give out these weird colors when it has different temperature. And for zinc oxide, it's supposed to be yellow when hot, white when cold. So since I know that this is zinc oxide for Z, then I know that the white solid W must be something of zinc. All right, must be something of zinc. So since it decomposes to form zinc oxide and one gas, which is V, then it's most likely carbon dioxide. There's only 2 possibilities over here. It's either a zinc nitrate or a zinc carbonate. And because it produces only 1 gas, not 2, if it was a nitrate, it would have produced 2 gases already, which is nitrogen dioxide and also oxygen gas. But the fact that it produces only 1 gas over here tells me that it is carbon dioxide gas. So therefore, you will get zinc oxide for Z and CO2 for both gas V. Then you will know that technically, if you were to have zinc carbonate reacting with nitric acid, you should get zinc nitrate. All right, so you get zinc nitrate, and you get carbon dioxide being produced and water being produced. So I've already explained to you how I get this answer all. W, B, Y, and Z all written here already, yeah? V is carbon dioxide, W is zinc carbonate, Y is zinc nitrate, and Z is zinc oxide. 4 marks in total for all correct answers. They ask you to describe the chemical test to verify the cation. In this case, the cation is supposed to be zinc. All right, zinc ion. And then the anion here is supposed to be nitrate, lah, okay? Because it's solution Y. So the test for zinc is very simple. I already explained to you over here. Test for zinc ion, just add a few drops of sodium hydroxide initially, followed by more sodium hydroxide, which means in excess. So we want to see whether what happens. And in this case, white color precipitate can actually form. But if you add even more sodium hydroxide, it dissolves in excess sodium hydroxide. So this test over here is an indication, a positive indication for zinc ions, where the white precipitate dissolves inside excess sodium hydroxide. To test for nitrate is very simple. You first add a few drops of nitric acid along the walls of the test tube. Then you add a little bit of iron 2 sulfate solution, okay, and then add a few drops of sulfuric acid along the wall. Once it drips all the way down, it reacts with the mixture, and you can suddenly see a brown color ring formation. So that's a positive indication of the nitrate ion. So these two will give you a total of 6 marks. Okay, explain how it is being done and what are the results, what are the outcome of the particular test. If you just do the test without showing the results, then you won't get full marks already. So you must explain the test for each and also explain the result for each. So in the process of explanation, you can also get 1 mark. So total, you get 6 marks in total. Okay. Also, name the reagents properly, yeah? All right, so next question, number 10. Number 10 says that polymer consists of natural polymer and synthetic polymer. They ask you to give one example of each. Very simple, okay? It can be anything. Natural polymer can be like, for example, silk, cellulose, rubber. You want to put cotton also can, things like that. And then for synthetic polymer, just choose any synthetic polymer, okay? It can be fabric, it can be plastic bottles, anything you want. So I give you some example here. Terylene, nylon, polyethylene, polyvinyl chloride, polystyrene. It's up to you, okay? As long as you state one example of each, you should get 2 marks in total. For the second question, diagram 10.1 shows the structural formula of 2 monomers to produce nylon in the laboratory. We have 1,6-diaminohexane and decanediol dichloride. They give you both structures, right? Now, you don't have to draw the structures, but they ask you to write a chemical equation for the formation of nylon. So what you can do is you can just technically condense this into molecular formula, and this one also as a molecular formula. Then you just combine them together only. But remember, this is actually a condensation reaction, which means to form new chemical bonds, to join these 2 monomers together in a long chain, there must be a removal of atoms. So remember, this is your functional group for both sides, and this one is your functional group for both sides also. All right? So when you want to form new chemical bonds between this N and this C, then you must take out something first. In this case, we'll take out this one and this one, combining together to form HCl, hydrogen chloride gas. So your equation then after that will be consisting of this one combining this one, and then after that plus HCl. You understand? So therefore, after that, I just condense it for you to show you this what's going on. Now I do also include the word N over here. I include N because we don't know how many molecules can join together. So N actually represents a very large number. Okay. So N C6H16N2 plus N C10H16Cl2O2, you'll get bracket the whole molecular formula C16H30N2O2, and then bracket the N at the bottom over here, which indicates that it's a long chain molecule consisting of N number of molecules, and also plus HCl. Write this correctly, you get 2 marks already. Okay, just follow back. I'll say just follow back the molecular formula based on these 2 structures. You shouldn't go wrong. Okay, diagram 10.2 shows how latex, which is produced from tapping the rubber tree, can be obtained. So you can see here, natural rubber is found in latex and is a type of natural polymer known as polyisoprene. It asks you to draw the structural formula of the monomer of natural rubber and give its IUPAC name. Okay, and also on top of that, state 3 characteristics of natural rubber. Now I don't have enough space to write everything over here, so actually, draw it over here. So you can see that this is actually supposed to be the rubber molecule, sorry, the molecule of rubber. So latex over here has 4 carbon atoms with 1 alkyl group attached to it. So to name this IUPAC structure is actually 2-methyl-but-1,3-diene. Okay, 2-methyl-but-1,3-diene, because there's 2 carbon-carbon double bond here. That's what's a diene, and there's one alkyl group, which is the methyl over here. So this is a 2-methyl-but-1,3-diene. And then you're supposed to state 3 characteristics of latex or natural rubber. So soft, elastic, heat and electrical insulator, easily oxidized and not heat resistant. All of these are characteristics of natural rubber or latex. So you can actually choose any 3 from this to get 3 marks in total. Do all this correctly, you should be able to get 5 marks. All right. Now it says here for number 2, latex obtained from tapped rubber trees will be collected immediately to prevent latex from coagulating. Explain how latex can coagulate. Describe one suitable method to prevent the latex from coagulating. Explain your answer. Okay, very simple. I actually prepared an answer in a separate paper. So naturally, we'll say that when you tap the rubber from the latex from the tree, right, it will naturally coagulate also, even though if you don't add acid inside. Now, back in what you have learned before in your chemistry syllabus in Form 5, you realize that latex, when you add acid, it will coagulate, it will come together, become hard. If you add a bit of alkaline solution, it will technically, they can actually prevent the coagulation of latex, okay? But if you leave latex by itself, exposed to air, they will also naturally coagulate also. But why? The answer is why, right? So this is the answer, the first part. How can latex coagulate? So latex can be exposed to air, and air got bacteria. So the bacteria can actually contaminate the latex and start to produce lactic acid. So once it produces lactic acid, like acid itself will produce hydrogen ions, right? So the membrane, the protein membrane of the rubber molecule is negatively charged. So when the hydrogen ions come close to the negatively charged membrane of the rubber molecule, they will start to neutralize the negative charges. So hydrogen ions neutralize the negative charges on the protein membrane, all right, and causes the protein membrane to become neutral after this. So once they're neutral, right, adjacent rubber molecules can come close to each other and start to collide against each other. And once they collide again, right, because the membrane is very thin and very fragile, they'll start to break. So you can see here the particles will collide against each other, causing membranes to actually break. And then the rubber polymers can then combine with each other and cause coagulation process. So that's how generally coagulation of latex can happen, even if you don't actually add acid inside. Bacteria can actually cause the coagulation by producing lactic acid. Now, how do we actually prevent that from happening? So after the farmers or the rubber tappers were to tap the rubber out, once the latex flow into that, the smaller cup that you see, then what I do is that they will actually add a bit of ammonia. So that's a solution. You add ammonia solution. So what does it do then, right? Well, how does that ammonia can prevent the coagulation of latex? So the hydroxide ions from the ammonia solution can actually neutralize any hydrogen ions that's being produced by the bacteria. So if the hydroxide from the ammonia can neutralize the hydrogen ions from the bacteria, then the protein membranes, the negatively charged protein membranes on the rubber molecule will not be able to be neutralized. So once they stay negatively charged, they'll try to repel one another as well. So if they can repel one another, of course, they can prevent collision of the molecules. And that's how, by adding a little bit of ammonia solution, can actually prevent the collision of the rubber molecules against each other. And it also can cause to prevent the coagulation of latex from happening. So that's the mechanism, and this is how you should describe it in your answer to get full marks. So going back to the question. Okay, if you were to answer all those correctly, you should be able to get 8 marks in total. All right, the breakdown of the answers now, you can see you can get 8 marks in total. All right, then they say here, the next question, natural rubber is not suitable for making vehicle tires. Okay, just justify the above statement. So 3 marks in total. So first and foremost, natural rubber is soft. And the worst of all, it is not heat resistant. When you drive your car on the road, the tires must go on the surface of the road and friction against the road. That creates heat. When heat is created, the tires, if it's made of natural rubber, will start to melt. So I say over here, when tires move on the road, they friction against the surface of the road. Then you can see here that high temperatures will cause the tires to melt and becomes very sticky. Imagine you use natural rubber, right? And then you put into your car as your car tires, right? You want to drive from KL to Kedah, or from Johor to KL, whatever lah. You realize that if you were to drive halfway, your tires are gone already. Why? Because natural rubber cannot withstand heat. So they'll melt. Or over time, if it melts, means your car tires will be gone. By the time you reach maybe 10 to 20 kilometers, your tire runs out already, gone already. So to overcome these problems, car tires are not natural rubbers. They are vulcanized rubber. So therefore, to overcome this problem, vulcanization of rubber can be done. Why? Because after you vulcanize the rubber, it becomes tougher. It becomes heat resistant. So it doesn't wear off that fast. I'm not saying that it won't wear off, but it won't wear off that fast. It takes much more time because it's more heat resistant. Doesn't melt that easily lah. That's what I'm trying to say. So the answer here will be all of that. If you answer them correctly, you should get 3 marks in total. All right, section C. Now, section C is 20 marks, but there's only one question. So you just answer that one question lah. Okay. So this is actually a very easy question. This is the last question already. So number 11 here, A, diagram 11 shows a structural formula of butene, all right, which carries the formula of technically C4, okay, C4H8. So they'll ask you to draw another 2 isomers, supposedly. Draw the structural formula of another 2 isomers of butene, and you're supposed to name each isomer according to IUPAC nomenclature. So I draw for you 2 structures already, okay? That's another way of drawing the same linear structure, but you just change the double bond to the second carbon atom. Okay, so from the top one, you see this now, this is actually called but1-ene. All right, this is but1-ene because this is carbon number 1. This is 2. So this one over here, this is 1, this is 2. So this is called but2-ene. And then the other one, okay, you can branch it out from the third carbon atom. The middle carbon atom. So this is the linear chain, and this is the branch, technically. So we call it as an alkyl group. So this is a methyl. The methyl is actually attached towards carbon number 2. So we call this as 2-methyl-propene, or 2-methyl-prop-1-ene also can, but it's usually just called 2-methyl-propene. Okay, so the 2 structures that you draw correctly and you name them correctly, you should be able to get 4 marks in total. Okay, very simple. All right, then B, 11B. So diagram 11.2 shows the conversions of several organic compounds. Compound X can change to ethanoic acid, and then ethanoic acid can undergo reaction 3 to form ethyl ethanoate. And then compound X can also undergo reaction number 2 to get ethene. So they ask you to actually write down all of the reactions and also name what compound X is, as well as its homologous series, followed by the molecular formula. So I've already mentioned all of this to you, okay, based on these red color markings. So compound X, after undergoing reaction number 1 to form ethanoic acid, right? And then after that, it undergoes another reaction to form ethyl ethanoate. So most likely, what happens here is that compound X is supposed to be ethanol, okay? Ethanol. Why ethanol? Because ethanol can undergo oxidation process in reaction 1 to produce ethanoic acid, right? Alcohols undergo oxidation to form a carboxylic acid. And then from the carboxylic acid that you can get here, you can react with more ethanol to form ethyl ethanoate in this reaction number 3. So reaction number 3 is actually esterification. Okay, so oxidation is down, esterification is down. Now, from compound X, assuming that it is already noted that it is ethanol, ethanol can actually undergo dehydration reaction to form ethene. So it all starts to make sense now, isn't it? So compound X is now definitely ethanol. And ethanol belongs to a homologous series of alcohol. And the molecular formula of ethanol is C2H5OH. You are also allowed to write C2H6O. All right, supposedly is correct lah, but of course we always use this to show the functional group of alcohol anyway. So C2H5OH is a better choice, but you can also choose to write this one if you want to. Okay, no restriction lah, I would say. So this is done. We already explained everything. Oh, before that, there's also one more. Draw an apparatus setup for reaction number 2, which means draw a setup for dehydration reaction of ethanol to ethene. So I've already drawn the structure for you. You can just take a look at this. So this is the one. So this is how you do it, okay? You have ethanol soaked in mineral wool, all right, or mineral wool. And after you have porcelain chips. So porcelain chips here is supposed to act as a catalyst. All right, and then after that, you'll be once the ethanol vapor undergoes through the porcelain chips, they'll be able to dehydrate itself, and then ethene gas will form on the side lah. So if you draw this whole structure labeled correctly, you don't have to draw the Bunsen burner. Like, I can just put heat here if you want to. All right, done already. Then this whole setup will be nice. Okay, but make sure it's labeled because it's supposed to be a labeled diagram. If you don't label the diagram, you might not get marks, full marks for it. So this is how it looks like. Okay. So once you get that done, you should be able to get 8 marks in total for all of the question. All right, next, the last question, number 2. Ethyl ethanoate has a sweet, fruity smell. Describe an experiment to prepare ethyl ethanoate in a laboratory through reaction number 3. A description should also contain the following procedures as well as the chemical equation. For procedure-wise, it's very simple. Okay, I've already prepared for you to answer. In this case here, you can just write, the procedure is very simple. Okay, you have technically just have a boiling tube. So you can pour 2 cm cube of glacial ethanoic acid and add 4 cm cube of ethanol. Right, you need to have 2 key ingredients here to actually get ethyl ethanoate. You need ethanoic acid and also ethanol. Then after that, you see here, you pour the 4 cm cube of ethanol into the glacial ethanoic acid, and they'll mix together. Okay, because your mix very well. Then after that, you can see here, add a few drops of concentrated sulfuric acid and shake the boiling tube. Concentrated sulfuric acid over here is supposed to be your catalyst. Okay, and also this technically is like a dehydrating reaction to remove the water. Because these 2 molecules, ethanoic acid, ethanol, they must undergo condensation reaction, right? They must remove certain atoms to accommodate new bonds. So concentrated sulfuric acid over here will act as your catalyst for the reaction, technically. Okay. Then after that, you can see that third step is to heat the mixture gently until the mixture boils for around 3 minutes. And then after that, you pour the content into a boiling tube. Pour the content on the boiling tube to a beaker half filled with water. And then after, supposed to record observation. Now, the idea is very simple. Supposedly, after you do all these steps already, you pour in the mixture or the substance that you created. In that case, it will be ethyl ethanoate lah. You pour into the water, right? The ester will form a layer on top of that beaker of water because it won't be able to solubilize in water, right? It's a covalent compound. So it will remain in one layer over there. And also you have a very nice fruity smell that you can smell. So those are the observations. But you don't have to write observation here because they didn't ask you for the results. They just ask you how to do this experiment, that's it. So stop at the last part here with number 5 law, record the observations. Okay. Now the last one, chemical equation. So very simple. We have ethanol, okay, reacting with ethanoic acid. So there must be part of the equation. And then after that, you just write the formula of ester, ethyl ethanoate. Just combine the 2 structures together. Okay. Remember, you already removed off the H from the ethanol and then the OH from the carboxylic acid. So combine this end here to that end you should be able to get this structure. Okay, you're supposed to get this structure over here. And of course, like I said, because this H is removed and this OH is already removed, you should be able to get H2O, which is then written over here. So the esterification process produces water as well, besides the ester. Okay, so that's pretty much about the explanation I can give you for this particular paper. I hope this particular paper and this discussion will be able to benefit you in certain ways to improve in your chemistry. All right, so this is Walter, and I'm from EduKaji. So I'll see you guys in the next video.